Can I share?
Yes, you can.
Okay, thanks.
Hello, sir.
Hi, Tino. Can you hear me? Hello? Hello?
Yes, sir. I can hear you.
Okay, if everyone can hear me, it's okay. So the next chapter that we're looking at is cluster analysis. I'm sure if you've Googled or if you've gone online about data science, you may have met something on cluster analysis, right? So I expect you guys to be competent enough to, by the end of this chapter, to be able to write an analysis on cluster analysis, right? Or a report on cluster analysis. All right. So by the end of this chapter, I'm sure by next week, this time, I'll be giving you an assignment on cluster analysis. So I'll give you the expectation of the assignments. I want an assignment to be more of a report style rather than a theoretical aspect. So yeah, what you'll be doing, the programming that you do, it's your own baby to care. but I'm not concerned about the programming. I'm concerned about how you tell us the story about the results. That should be your mandate. So let's look at clustering. So I'm sure you still remember we talked about unsupervised learning technique is the one that requires only the input, right? So clustering is one of the unsupervised learning technique in machine learning. Its purpose is to come up with natural groupings of instances given unlabeled data. So you need to know that you're only given an input data and no output data, and the data is unlabeled, and we're supposed to come up with natural grouping. So the grouping may be based on some similarity or some dissimilarities. So you need to look at those aspects. So clustering is a technique of data segmentation that partitions the data into several groups based on their similarity. So, for example, I want to give you an example, I'm sure, which is a famous example online. Let me give it in a context of Zimbabwe, or specifically a Harare setup. All right. Suppose you want to set a wine shop in Harare, right? Probably you go to different supermarkets, right? In those supermarkets, when suppose you're swiping or you're doing a transaction, right? They capture the details of the people where they are located to, right? Suppose we've got different wines that we have, right? Those are those are our variables. Probably we've got 10 wines that are different, and you want to identify the suitable location, or a particular location where you can make your profits, right? Maximize on your profits. So you would want to capture information about the location of the clients that are buying those wines. Then you would come up with clustering techniques that you're going to use so that you can cluster the clients or the customers from different supermarkets where they are located from. So you'll be able to tell, which area probably is most likely to have more customers of a particular wine. So that's a group on its own. So you would know the cluster of a particular wine, or which is more frequently bought from supermarkets, and you know the site where you can place the supermarket for the wines and the type of wine that is favored in that particular area. So you get to read about clustering online. You get to hear more about data segmentation. All right. So these groups are formed from a bigger data known as clusters. Right. These clusters exhibit the following properties. They are discovered while carrying out the operation, and the knowledge of their number is not known in advance. Other thing that you need to know about clusters is that clusters are the aggregation of similar objects that share common characteristics. That's what I was saying. Probably you'd get a group of people who favor a particular wine in a particular area. So they share a common characteristic. So clustering is the most widespread and popular method of data analysis and data mining. Most of these are centered around association between sample units and how similar, or better still, how dissimilar two clusters are. So mainly clustering is we're dealing with is a technique of data segmentation that partitions data into several groups based on on their similarity. Now let's look at the application of clustering. Clustering can be applied in marketing, can be applied in retail, can be applied in medicine, can be applied in sociology. So in many aspects of life, we can apply clustering. Let's look at example in marketing. In the area of marketing, we use clustering to explore and select customers that are potential buyers of a product. This is the example that I was giving you in terms of the customers that favor a particular wine. So you're able to select customers that are potential buyers of the product. For example, yeah, let me give you an example here in Zimbabwe. You can't go and which products probably are suited for. Suppose you stay in Kwadzan, right? And then you go and sell Lamborghinis in that area, right? People wouldn't buy those cars. They want cars that are affordable to them. They want cars that are efficient to them, right? But you see, you better take those cars probably to Borodale. Some guys in Borodale, they may buy it. So you're looking at how you select your customers that are potential buyers of a particular of a particular product. You don't just place your shop, or you don't just go and sell anything from any location. You have to study the market. It's called market analysis. So after the clusters have been developed, business can track of their customers and make necessary decisions to retain them in that cluster, right? So suppose you're working with Econet, right? You want to find some particular characteristics of your clients, right? And you be able to know how you can deal with those clients at a particular time. So you need to know how, you need to imagine a situation where you can group, or where grouping is necessary, and what comes out of that grouping. Then we look at retail. Retail industry make use of clustering to group customers based on their preferences, style, choice of wear, as well as store preferences. This allows them to manage their stores in as much as more efficient manner. I'm sure you've got into supermarkets and you realize how they arrange their products, right? You definitely see probably there's sugar on your left. The next, it might be what you call tea bags or coffee, right? Those are food types that have been grouped together. That shows a similarity in terms of how they are used at at their places. If you get to a supermarket, you see you've got chickens, and then you get to see spices, right? You get to see salt. All those things, they are grouped based on their similarity or in terms of how you use them. So you can apply cluster analysis in many fields. Probably in medicine. Let's look at medicine. Medical science, medicine and health industry makes use of clustering algorithms to facilitate efficient diagnosis and the treatment of their patient, as well as the discovery of their new medicines. So look at it right now. We have got vaccines that have been rolled out right across the world, right? So let's look at probably the effectiveness of each particular drug, or the choice of each particular vaccine. You realize some vaccines are more likely to be in a particular region, right, than another particular region. So if people are to be, or a data is on the site about vaccine, you would realize that you can come up with groups or types of vaccine that are being used around the world. Another way is social clustering is used in data mining operations to divide people based on their demographics, lifestyle, socioeconomic status, etc. This can help the law enforcement agencies to group potential criminals and even identify them with efficient implementation of the clustering algorithm. I think if you get online again, there's a data that it deals with crimes in United States of America and their locations, right? So suppose the boss of FBI, right? You want to distribute your police force, right? And you want to know how many police force officers do you deploy to a particular, probably Chicago, right? You have to know the crime rate of Chicago. So how are you going to know the crime rate of Chicago? You have to do cluster analysis to group uh, states based on on the crime rate. So you get that data online again. So you'll be able to know which particular area, and even in Zimbabwe right now, suppose we are towards elections, right? You know the information of crime rate or drug abuse or something that relates with violence and the the commissioners, they will know how to deploy the number of people. You can't deploy more people in a town where it's less violent. So based on the information that we have, we can come up with cluster analysis, and then from that information, we can help to make decisions. So now, based on clustering, when you're saying it's either there's some similarity or dissimilarity in terms of variables. So what's key is to be able to obtain distance measures that will enable you to find a certain particular cluster or a particular group or a particular segmentation. So distance measures are the ones that helps us to come up with that similarity of items, of people, or of their characteristics. So you've got the Euclidean distance, you've got the squared Euclidean distance, you've got the city block distance, you've got the Mahalanobis distance. All these are distance measures, right, that you can use to come up with similarity or similarities of the characteristics that you are looking at, right? So these are basically required for you to calculate the difference between object 1 and object 2. So we've got 4 clustering methods that we're going to focus on this course, all right? 4 clustering methods. So we've got non-hierarchical algorithm, you've got the hierarchical methods, you've got the fuzzy clustering, you've got the model-based methods. So these are 4 types of clustering that we're going to focus on. So in non-hierarchical clustering, here the data is initially partitioned into K clusters. Observations are placed into these clusters based on arbitrary assignment, known as the seed points. So you've got what is called the K-means under non-hierarchical algorithm that we're going to look at it. And then we've got hierarchical methods, which is divided into 2, right? Which is agglomerative hierarchical algorithm and divisive hierarchical algorithm. So we are going to get into detail about these when we're now doing the programming. That'll be next week on Tuesday, right? Yes. So get to do more of programming in this on how you determine the number of clusters given a particular data. We've got the fuzzy clustering. All right, this is another clustering technique based on the fuzzy statistics. Mainly, this is related to probability. So how closer a particular probability situation, it's how you can come up with that grouping. Then we've got the model-based method. Model-based methods use a mixture of models to specify distinct functions of all the variables in the data. So this one is based on different mixture of models. Suppose you've got a normal distribution and a mixture of normal distribution brings out a model-based method. So you also need to know the difference between hierarchical and non-hierarchical. I think this will make sense when you're now looking at the practical part of it, and then you'll be able to tell what's the difference between hierarchical clustering and non-hierarchical clustering. But I'm sure from these points you can pick out the difference. So yeah, so we're saying hierarchical clustering is basically an unsupervised clustering technique, which involves creating clusters in a predefined order, right? And we are saying the clusters are ordered in top of bottom manner. In this type of clustering, similar clusters are grouped together and arranged in a hierarchical manner. It can be further divided into 2 that we've discussed above, right? And then you look at non-hierarchical clustering involves formation of new clusters by merging or splitting the clusters. So you can look at this and then you ask yourself there are differences that you can pick out from there. So yeah. So I think on Tuesday I'll give you a tutorial based on the introduction and what we have covered up to now. So the issue is that I'm making videos so short so that the other guys they can access the videos other than a 2-hour video where it will be too long, right? So you need to balance the two, right? People don't have data. I don't know if the Econet is provided you the data this semester, I'm not sure. But we need to strike the balance. So that's why I give you probably 30 minutes lecture, 30 to 45 minutes lecture, it'll be okay. And then probably 30 minutes lecture and then 15 minutes questions so that we understand other people. And then good clustering. So when do we say a cluster is good? This is what you are expected to know. Because when the time we start doing the programming, you have to know this clustering technique on how they behave. So a good clustering method should be lead to a clear defined clusters within cluster similarity and high and intercluster similarity low. So you need a similarity to be high and intercluster similarity to be what? To be low, right? That's another point. Should depend on both similarity measure used by methods and its implementation. Should also be measured by its ability to discover hidden patterns. These are three points that distinguish that gives us an insight to say what is a good cluster or what's a good clustering method. And that's it. So the problem is that the objective evaluation is not easy as it is often done by human inspections. K-means clustering is a partitioning technique. It partitions data into K distinct non-overlapping clusters. That is a key aspect, non-overlapping clusters. So you realize, I'm sure you did sets at all level, right? It's more of like sets that what you're doing here, but we don't want a situation where sets they overlap. That's a bad type of clustering. So we will try by all means to minimize, but somehow it depends on a particular data. Some data they bring out distinct clusters which are separate, which are disjoint. But somehow you may deal with the situation where these clusters overlap, but you have to minimize it and able to charge based on the visual inspection. So that's the introduction about clustering. So we have to get now to deep into these methods of clustering, the hierarchical, non-hierarchical, fuzzy, and model-based. So if you're good, you can get something on clustering online. Try start learning. Get on YouTube. All right, learn more about it. All right, get on internet, Google about clustering, and they can give you examples and how you operate them and how you interpret them. Right. But all I'm saying is, if I give you an assignment, it will be a report style. Probably I may say it should be 4 pages or 3 pages. 3 pages are enough just to write a story about the data that you have. So right now, probably what you can do in preparation for the assignment, go online and get any data, all right, for clustering. But the data should not be the same. We are 40 students, 41 students, I'm sure. If you're 41 students, everyone has to get his or her particular data that is going to use for an assignment. No one is going to share the data. So what you do is, when you get your first data, submit your name and the type of data that you have to Tino. When Tino, if you realize that somebody has used another person's data, you tell the person that data has been taken by somebody. All right. In R, there are lots of data. All right. In R, there are lots of data. Online, there are lots of data. You can get them. But no one should use iris data. No one should use the iris data, because I know the iris data is the most famous data for clustering. Everyone can use it because it's easy. Right. They have programmed it so that they can use it as an example for that. Or do you want it as a group assignment or as an individual assignment? Let me confirm that way. Do you want it as an individual or a group assignment? Because now I've assigned you to get the data that you're going to use for the assignment. So you have to look for data that deals with clustering online. Do you want it as a group assignment or as an individual assignment? So anyone, you can participate now. Or Tino, you come back to me concerning that.
Oh, okay, sir.
We discuss with other guys. I think it would be ideal for you guys to do as a group. You learn more, right? So suppose you have 40 of you, right? Per group, if you say 5, that will be okay. So why is it that I want you to get the data? So that when I'll be doing k-means clustering, you're also doing k-means clustering with your own particular data. So that by the time I finish clustering, you'll be also completing what? Your assignment. So give me the feedback by end of day today.
Okay, so
Are
it's fine.
there any questions? Any questions? If there are no questions, let's end the lecture now.
Sir.
Yes, go ahead.
Thank you. Can you allow us to ask questions on the next lecture, since we didn't have the notes? So would like
it's still okay
to,
because the notes that I sent you, I'll update. I'll add more stuff, and then I'll update them, and then I'll send you the updated ones.
Okay, it's fine.
So let's meet on Tuesday.